everybody. Welcome to another week. This is week number 12, and we are studying simple, series, and parallel circuits.
You can see the simple, the series, and the parallel. And you will see the difference between all of those three. So how can you electrocute yourself?
So think about it. How can you get a shock? Or rather, why do you get a shock when you put your finger inside an electric socket? Okay. So a lot of that has to do with the fact that when you put your finger in the socket, you actually complete the circuit. So the electricity flows through your body and flows back into the socket. So then because you're conducting electricity, you get a shock. So here we come to the purpose. Today we will learn about three types of circuits to be able to draw a mind map and design an experiment for electric circuits by explaining the process and results of connecting electric cells in series and parallel circuit, together with realizing benefits of connecting electric cells in series circuit by being able to tell its benefits and applications.
Okay, let's come to the vocabulary. The first one, simple. So the simple circuit, that's just one battery and at least one bulb and the wire. This is a simple circuit with nothing else.
Okay, and the second word is parallel. So parallel lines are lines which are aligned with each other and they don't meet. So the railroad tracks are parallel. Okay, now from here, it means in electrical circuits, when two bulbs are next to each other, connected to the battery directly, but are not on the same line, okay, then that is a parallel circuit.
Then the series, the noun. So this is almost same like a parallel, but doesn't need to be in parallel. So on the circuit, you will have at least two bulbs or more, and at least one battery to complete the circuit.
And the last is conduct. So conduct is a verb which means allows. Okay, so here it means to allow electricity to flow through.
So we started the video to understand a bit better the simple circuit.
Even if you don't totally understand what electricity is, you are probably very familiar with it and use it throughout your day. When you turn on lights in your room when you wake up in the morning, when you use your electric toothbrush to brush your teeth, when you use your toaster to toast your bagels for breakfast, and of course, you used it when you turned on your computer and brought up this video. Exactly what electricity is can be kind of an abstract concept, but for now I want you to think of it as tiny particles that we call electrons. But how do these electrons make all of these different appliances work? It turns out that on their own, the electrons don't do much. But when they move, their movement generates energy, and that can power all of these different things. To talk about how this works, we are going to use a really simple example that I have drawn out here. And this is a very simple version of a flashlight or a torch. So here we have a light, and this light is attached by two wires to a battery. And when all of these things are connected in a loop, we say that we have an electric circuit. In this case, a very simple one. Electrons can flow through this loop, which we call an electric current. And as this happens, it can turn up lights, move motors, and heat things up. But no matter what job it's doing, we can always think of a circuit as a path through which electricity flows. There are a few things that I want to point out about this circuit. First, I want us to look at the battery. And the battery provides the power that causes the electricity to move around the circuit. And this battery, in fact all batteries, have a positive end and a negative end. Electrons are pushed out from the negative end and move towards the positive end. And the wires provide the path that the electrons can move through. Another thing you need to know about this circuit is that it only works if it is closed. If there is a break anywhere in the circuit, like if a wire was broken or not connected to the battery, the circuit wouldn't be complete and the light would no longer light up. And we could make this circuit a little bit more complicated by adding things like other lights, but we could also add things like switches. Switches are components that purposefully break the circuit, but then they allow you to open and close it as needed. So think about a light switch. When the switch is down, the circuit is broken and the light is off. But when you turn the switch on, it completes the circuit, it closes it, and this allows the light to turn on.
Okay, welcome back. So just from the video, you realized what a simple circuit was. So you have a battery and a bulb, and they are connected with a wire. So this is your simple circuit. Okay, going next, this is your series circuit. So as you can see, the two bulbs are connected directly to the battery, and they are connected next to each other. Okay, so that is a series circuit. And finally, we have the parallel circuit. So the two bulbs are connected to the same battery, but they are not on the same line. They are on parallel or different lines. Okay. So here we have a website for you to do your thinking tool. So this website allows you to drag and drop the battery, the wire, and the bulb, and you can play around with it. So you can make a series circuit, you can make a parallel circuit. Just don't forget that it is free, so you will not have unlimited animation. So be very careful with the animation. So use a switch and keep the switch off when you don't want the electricity to flow through. Okay, but try a series circuit, try simple circuit, and try parallel circuit at this website.
This is a short video to show how to use the circuit construction kit for the PhET simulation. So I've already opened the intro lab, and you can basically just drag components into the blue part of the screen, and you can grab some wires. And then the other thing to keep in mind is if you want to rotate the wires or the battery, you just grab one piece, one end, and then you just hold it, and with your mouse you rotate it. And you can always disconnect things as well. So I'm going to go ahead and just connect these together where they meet. And I'm going to do the same thing on the bottom. And then we can see how the light bulb lights up. I'm going to put a switch in so we can also see how the switch works. So I'm going to turn the switch to the side. And so you have to actually use quite a few wires if you want to make it look, kind of square. So here we go. Alright, so it's not on right now. I can click on the battery. If I wanted to remove it, I could hit the trash can. I can also change the voltage, so I'm going to go ahead and up the voltage. And you can change the resistance of the light bulb, but for now we're just going to leave it set at 10, so I don't want that to be adjusted at the moment. And so then you can grab onto the switch and you can close it, and the light bulb lights up, and the brightness of the bulb will change if you change the voltage. So if I drop the voltage, you can tell that it's not as bright. If I increase the voltage, it gets to be larger. I can also see the current that's flowing. This is the electron current. You can actually see the electrons, the negative charge. I could use conventional current, and that just means it's the flow of positive charge, and it shows it moving the other way. And I'm just clicking up on the top, and then I could also show values if I wanted to. I really would prefer that one not to be used at the moment. And then you can use the meters that are on the side here. So if you wanted to measure voltage, you grab the voltmeter, you pull it around to where you want it, and then if I wanted to know what the voltage was across the battery, I put it across the ends of the battery, and it reads what the voltage is. Now in this case it's reading a negative 47 5, and it really doesn't matter. The negative sign doesn't matter. It's just the polarity. So if I switched these, it would read the same value, just positive. So we would record the positive value. And we could do the same thing for measuring the voltage across the light bulb, and that tells us what that voltage is. So if you're done with that, you can put it back, and then you can grab the other meter which measures current, and to measure the current you just have to take this part that looks like a crosshair and put it over the wire that you're interested in measuring the current, and then that tells you what the current is. If you were opening this up on a device that was embedded into a HTML file, so in other words, if you were opening in a web browser, you could also make this bigger. So if you go over here to where the FET is on the side and you click, there's options, and one of those is to enter the full screen mode. I'm not going to do that, but you could enter full screen and it'll take up your whole screen, and then you can just exit out of that. You can also change the size, so you can decrease if you need more space to build your circuit. You can decrease that as well. So the best thing to do is to play around with it. And then over on the side there's an up and down arrows, and there's some other options. So you can insert a paper clip. So if I pulled this in here, let's enlarge it. Oh, grab that paper clip, enlarge it. You could put the paper clip in the circuit. So you can click on one of these where the connections are. If you hit the scissors, it disconnects it, and then you could insert the paper clip in that place and see what happens. I'm not going to do that because that's something that you would have to do, but there's other items that are there to use, and then if you're done with that item, you could grab it and just put it back and use it. So I think that gives an overview of how this particular simulation works, and you use the same simulation for the first 3 lab activities. This is
the experiment that we did normally at school. You can just watch the video now, then see what you can do with a battery, aluminium, and a bulb.
Welcome to Kids Fun Science. My name's Ken, and today's experiment is making a simple circuit. As always, adult supervision is required. What you'll need for this experiment is aluminum foil, scissors, Scotch tape, a 9-volt battery, a piece of paper, and Christmas lights. Hi, welcome. My name's Ken, and today we're going to be making a simple circuit. What is a simple circuit? It's a path of electricity that flows along. It starts from the power source like a battery and flows through the wires to the light bulb and back to the power source. What we need for this experiment is a 9-volt battery. Well, you can use any battery. We're going to use a 9-volt battery, a piece of paper, Scotch tape, scissors, and aluminum foil. And if you have an old Christmas lights, you cut those up and get those ready so we can expose the wires. And what we're going to do is take the aluminum foil. What we're going to do here is take the aluminum foil and we're going to cut it in strips. Make two or three strips. And then we're going to start putting these strips together and taping them down onto the paper. What we do is we're going to use the aluminum foil as our wire. And we're going to, I just usually fold it over. You don't need to do that. Just fold it over once to get a nice bend there. And then you're going to take Scotch tape and say we bend it up this way. And I'll tape this corner right here. And then we'll bring it straight along here and up there. And we're going to tape this end here. And we're going to take our second piece. You want to leave a little bit of a gap. You kind of just kind of pinch it around to make a corner. And you're going to leave a little bit of gap in between the tin foil there on the bottom part here. I'll show you in a second. And then I'm just going to make a run this way. And we're probably going to need another piece. Take this corner down here. Cut this piece here. I just made a smaller piece, cut it in half. And put it right there. So what we have here is a little bit of a gap here and a little bit of a gap right here. Then you're going to take your Christmas lights that we cut off, right? Make sure it's not plugged in when you're making these cuts. Pull off the ends so we have the wires exposed. And then we're going to tape them on down here. So it's standing straight up. You want the light bulb to stand straight up. Tape one end on each of the foil. As like this. And now to get it to work, I'll dim the lights a little. And take your battery, it doesn't matter positive or negative, and we're going to place it right on each side of the aluminum here. Voila! There it goes. And all we do is to come up here, you're just taking it here. Alright, we're going to add a second light bulb. So I cut out a section right here, as you can see. And I'm going to take another set of lights, getting the wires tight here, and we're going to tape those down onto the foil. So as long as it's the exposed is taped there, and the light bulb, you want it to stand up. So now I have two light bulbs there, as you can see, in the gaps, and there's one gap here. So when we take our battery once again, it doesn't matter positive or negative, and place it on each end. See, it's a little bit lower voltage because it's powering 2, but there it goes. So you could see how many light bulbs you could add in and see if the 9-volt battery can support it. All right, I hope you enjoyed this video, and remember to click thumbs up and to subscribe. Thanks for watching.
Okay, welcome back. So now that you know the simple series and the parallel circuits, we want you to draw a diagram. So draw a diagram with the 3 in 3 different circles, and write down the main differences between a simple series and parallel circuit.
Then explain your brain pop circuit from the website.
So in the website, we gave you an exercise to draw simple series and parallel circuits and to play around with it. And you can add as many bulbs as you want. You can add as many fans as you want. And then just make a small note about what you have drawn.
Okay, see you for the next video. Bye-bye.